guys, today we are covering section 1.3. The target here is that we can estimate the value of irrational numbers, right? You know there are three types of irrational numbers that we talked about last section. You got pi, which most people already know how to estimate. You've got decimals that make a pattern but not a repeating pattern. So to estimate those, you would just round them to a certain decimal point. The big thing we're going to look at today is how to estimate the value of a square root when it is not a perfect square. And we're going to try to do this without a calculator so that we get some number sense here. And without having to go to a calculator, we have an idea of what the answer already is. All right, to do this, we're going to do a quick review of square roots. Square roots come from finding the area of a shape. Did you know that? Back a long time ago, maybe the Greeks, they came up with these terms, square and square root. Guess what shape square roots are related to? I think we know. The area of a square is equal to the length of one side of the square multiplied by itself. Think about that. I have a square and it has a side length of 5. And we all know how to calculate the area of a square, right? You do length times width, like a rectangle. So the area of a square of this square is equal to 5 times 5. And a different way to write 5 times 5, of course, is 5 squared. Why is it called squared? Because when you multiply a number by itself, you're finding the area of a square that has that side length, right? The area of this square, of course, would be 25. So the thing is, what's the relationship between these two numbers, right? 25 is the square of 5, or if you reverse that, you know that 5 is the square root of 25, which takes us to this other example. If you know the area of a square, you can find the side length by reversing the squaring, and let's take the square root. So if I have a square whose area is 49, I can find the side length by taking the square root of the area. All right? The function square root finds a number that when multiplied by itself equals the original number. All right, that's where squares and square roots originated from and why they're called squares and square roots. Let's do a quick review of the square root function. The square root of h would be a number that when multiplied by itself equals what? Let's see. The square root of h would be some number that when multiplied by itself equals h. Right? That's what a square root is. It's a number that when multiplied by itself equals the number under the square root sign. Of course, we learned this yesterday or day before, or maybe last year. The symbol for square root is that. It is called a square root sign, but there's a cooler name for it. It's also called a radical sign. In fact, I like saying radical better than I like saying square root of. So if you had the square root of 10, of course that could be read the square root of 10, or it could also be read radical 10. And again, I like saying radical 10 better than the square root of 10. Some people simplify the square root of 10 and just say root 10, which kind of means the same thing as the square root of 10. The number under the square root sign, here's a new vocabulary word for you. The number under the square root sign has a name. It's called the radicand. And I will use that throughout the year. It's a good word to know. The radicand refers to whatever amount is under the square root sign. And every positive number, did you know, has two square roots? One positive and one negative. You know, we don't use the negative square root very often, but there are occasions this year we will use it. In general, though, you can just use the positive square root unless you're told to use the negative and the positive. Let me show you why that's true. We'll go back to the square root of 49. What's the square root of 49? Well, we all know it's 7, right? Why is it 7? Well, the square root of 49 is 7, since 7 times 7 is 49. But I claim that the square root of 49 could also be negative 7. Why? Because negative 7 times negative 7 also equals 49. So my point is, technically, 49 has two square roots, a positive and a negative. All positive numbers would have two square roots. There's only one number that would have one square root, and that is 0. And there are some numbers that have no square roots. Do you know what those are? All right, we filled out this chart once already. Remember, this is a little bit of a challenge. How quickly can you name perfect squares up to 100? How well do you know your perfect squares? I'm going to put them in. It's really not that hard to write them almost as quickly as I did, because perfect squares are simply a number squared. So all you got to do in your head is go 1 times 1, 2 times 2, 3 times 3, and so on. All the way up to 10 times 10. And you have named your perfect squares. All right, well, the goal for today is to be able to take numbers and estimate their square roots. Now, that's easy when you have perfect squares. Finding the square root of a perfect square, no problem whatsoever. Let's see. So when you see a square root sign on a number, your goal is to find a number that when multiplied by itself equals the radicand. All right, good use of the word there. Well, this is easy when it's a perfect square. And again, we're just going to name the positive square root. The square root of 49, of course, that's 7. That seems to be my favorite number today. The square root of 25, we all know that's 5. The square root of 64, that's 8. Finding the square root of a perfect square, no problem. How about the square roots of non-perfect squares? Well, these aren't quite so easy, because as we know, the square root of a non-perfect square is an irrational number. And as we know about irrational numbers, they are decimals that are non-terminating, non-repeating. So they don't have exact values. You can't really name the square root of a non-perfect square exactly. So these square roots, if we can't name them exactly, are going to have their values estimated. Or, I didn't want to use the word estimated, approximated is what I'm looking for. And I would like you to be able to approximate the square root of any number in your head. So here's how we do it. I have this little process. It's not that hard. The first thing you want to do is you want to think about two perfect squares, the two perfect squares that your number is between. And again, that gets to how well do you know your perfect squares. Think about which one it's closer to and then estimate it. I've done an example here to show you how to go through those steps. So we have the square root of 22. The first thing I want to do is determine what two numbers is what two perfect squares is the square root of 22 between? Well, it's between the square root of 16 and the square root of 25. So the square root of 22 is going to have the square root will be between the square roots of 16 and 25. So its square root will be between 4 and 5. That's a pretty good estimate already. I know that the square root of 22 is more than 4, but less than 5. But I want you to narrow it down just a little bit more. What number is 22 closer to? Is 22 closer to 16 or is it closer to 25? Well, it's closer to 25. So that means that its square root will be closer to 5, right? So when I make my estimate, I want to pick a number that's between 4 and 5, but I want to go closer to 5. So I want to go more than 4.5. And I would, for 22, probably go about 4.7. The closer to 25, the higher I would have made it. If it had been 24, I might have gone 4.9. So my estimate would be, 4.7. I guess I meant that to be a 5. The square root is closer to 5, so I'm going to estimate 4.7. And then I want you to graph this on a number line. So I'm going to number the number line and then put that where it belongs. So when I write the number on the number line, I'm going to call it the square root of 22. I'm not going to call it my estimate. And the red dot there would be about where the square root of 22 is. It's between 4 and 5, but closer to 5. Let's do a few examples, and we'll be done. All right, so I have 3 examples here. Again, if you want to turn off the video and then try it yourself and come back, give it a shot. Let me go over them. So I'm going to try to estimate each one the same way I did before. First, I'm going to name 2 perfect squares on each side. So 7 is between the square root of 4 and the square root of 9, which means its square root is between 2 and 3. And 7 is closer to 9, so its square root is going to be closer to 3, and I would probably go about 2.6. The square root of 40. The square root of 40 is between what 2 perfect squares? It's between 36 and 49. Which means the square root of 40 is going to be between 6 and 7. 40 is closer to 36, so its square root is closer to 6, and I'm going to make it about 6.2. The little squiggly lines, of course, mean approximately, right? And last up, 79. 79 is between 64 and 81. So that means its square root is between 8 and 9. And in this case, it is much closer to 9. 79 is much closer to 81. So I'm going to say it's approximately 8.8. All right. So to graph these, I would go to the first one, I'd go to about 2.6. That's a little bit closer to 3. There's the square root of 7. 6.2. There's the square root of 40. And last up, square root of 79 is about 8.8. And there's the square root of 79. At the end here, I had 3, I think, thought-provoking questions. Between which 2 whole numbers would you find the square? Okay, again, try turning the video off and getting these yourself, and then turning it back on and see how you did. What 2 whole numbers is the square root of 70 between? Well, again, it's between 64 and 81, so it would be between 8 and 9. Number 2, the square root of an integer n is between 9 and 10. The square root of n equals somewhere from 9 to 10. That means n has got to be between 81 and 100. So n could equal 82, 83, 84, 98, 99. Those are all the possible values of n if its square root is between 9 and 10. And last up, what is the exact decimal value for the square root of 50? You can't do it. It doesn't have an exact value. The key word there is exact, and the square root of 50 is irrational, so it does not have it. It's a non-terminating, non-repeating decimal. It doesn't have an exact value. Hope that helps. Good luck.